the stage is now yours.
Thank you very much, Peter. Let me start the presentation and then I share my screen.
Yeah, now it's starting. Okay, I see it.
Okay, thank you very much. So I'm Marc, the CEO of Euresis. Today we talk about Open eVision and more particularly our Open eVision, of course, deep learning tools. A word about Euresis first. Euresis is a company from Europe. Actually, the head office is in Belgium, but we also have an R&D center in Germany with the company Sensor to Image, close to Munich. We sell our products worldwide. We sell computer vision components. We sell computer vision components worldwide through a network of distributors, but we also have sales and support offices in California, in Singapore, in Shanghai, and then in Japan. We are probably best known for our set of frame grabbers, but today we talk about Open eVision, and Open eVision is a super important product for Euresis. Open eVision is a set of image analysis libraries and other software tools. So you see the set of libraries that we have here in Open eVision. They are libraries that we have been developing for more than 20 years now. They include alignment libraries, color analysis, object detection, then we do OCR, code reading, pattern matching, subpixel measurement, and then more recently we have focused on the 3D image processing, and we can do now object detection and measurement on point cloud, and deep learning with our latest libraries, which are Easy Classify and Easy Segment. As I said, these are image analysis libraries. So at Euresis, we don't make machines, we don't make systems. We build components, and in this case, we build libraries that are integrated into your application, I would say, if you are interested in our products. So our libraries are integrated into systems, into machines, into inspection machines all over the world. They are hardware-independent libraries. They do not rely typically on a specific hardware. They are compatible with any image source. So you can use the Open eVision libraries even if you do not use even if you do not use Euresis frame grabbers. You can use frame grabbers from the competition, or you can use no frame grabber at all, for example, with a Geeky Vision camera or a USB 3 Vision camera. The Open eVision libraries are 64-bit and 32-bit libraries. Actually, the deep learning libraries are 64-bit only because we need more memory and more processing power. They are compatible with Windows and x86 processor architecture, so you can use any type of a PC to develop your Open eVision application. We focus on helping our customers integrate our libraries into their application. So our libraries are well documented, they are easy to use, they are easy to learn, and they are robust and flexible. We have been developing them for so many years now. We have sold in excess of 300,000 licenses worldwide. So imagine the inspection machines that run Open eVision today. And we support the latest technologies, 3D, I've talked about it, and today we talk about deep learning. We have two and very soon three deep learning libraries in Open eVision. They are called Easy Classify for classification, Easy Segment for unsupervised and supervised segmentation, and by the end of this year, we will have a third library which is called Easy Locate for object detection. So I'm lucky today because you had two great presentations about deep learning already, so I don't have to go through all the steps, training and then inference and evaluation that we have already heard about today. So I will focus on the differences between these three libraries and actually four modes of operation that we have with easyClassify, Segment, and easyLocate. easyClassify is a classification library. During the training process, you provide it with a set of images, and each of these images has a label. In a simple application, the label can be whether the image is good or whether the image is bad, or it can be a label that associates the image with product number 1, product number 2, product number 3, or just, as everyone would say, tomatoes, potatoes, or apples. So these are examples of classification that we can do with easyClassify, classifying cookies or waffles into good or bad products. Challenging application here where we had to inspect the ceramic tiles. You see the good examples on the left and the defects that we can detect on the right. The broken tile here is quite easy to detect, but the glue that we had on these tiles here is more challenging. And then, of course, sorting products is also an interesting application. As I said, with classification, the library will associate a label to every image. So we don't have much information about how the library has reached that decision. We have some indication at the end, but basically the library will tell you whether the entire image is good or bad. With the segmentation and the easy segment library, then it's a different mode of working. We actually have much more information about the defects and the result. In production, so during inference, we get what we call the segmentation mask. The segmentation mask is a set of regions, areas, zones in the image, and each area will be attached to a defect. So if we have defects in the image, we will know exactly where they are in the image. There are two modes of segmentation in easy segment, the unsupervised segmentation and the supervised segmentation. Unsupervised segmentation requires only good images. And that's a very, very simple mode to use and to demonstrate. It's a mode that corresponds to a lot of application cases because it's sometimes very difficult to get clear images of defects. So with this unsupervised segmentation mode, we can train the tool with only good images. It cannot solve all the applications, but it's certainly a good way to start. With unsupervised segmentation, we don't need many images, 10 to 20 images, and then we are good to go. And you do not have to label or you do not have to annotate the images. Supervised segmentation will be used for more advanced cases where you need more information about the defects, or perhaps you have different kinds of defects, the scratches and then marks, and then in this case you wish to annotate the images. So I show you a few examples here of easy segment unsupervised defect segmentation. The same cookies we have on the left here. You see at the bottom of the image the kind of result that we can get. In red, overlaid in red here, we highlight the defects, and we can highlight them very, very precisely, so you know exactly where is the defect in the image. Here, these are examples with the cookies, with the fabric, or with the ceramic tiles. These are examples that we show where we can detect the defect without any supervision. So we have trained these data sets only with good images. There are more challenging examples here. These coffee beans on the left here. There's a foreign material here which we have been able to detect. This is the kind of application that we can solve using a supervised segmentation, so where we have to annotate the images and show the defects before the learning process. So instead of continuing and showing you many different cases and images, I'm going to use a real application, which is our Open eVision Deep Learning Studio. And what I'm trying to do now for the rest of the presentation, so I will reach almost the half of the presentation, I'm going to try to convince you to download our Deep Learning Studio and try it for yourself. Actually, our Open eVision Deep Learning Studio is free. You can download it from our website and you can test it using your own images. It does not require any license. The application is free in itself, but when we run the deep learning libraries inside Open eVision Deep Learning Studio, you don't need to purchase any license. You can try the tool with your own images as long as you want. So I'm going to find a way to switch to our Deep Learning Studio here. And then, okay, just imagine I just started the tool here. I'm just running the demonstration on a simple laptop here, so I have nothing special. I do not have a GPU here, so I click OK. And the Deep Learning Studio application asks me, do you want to use easy classify and easy segment? Do you want to use the classifiers, unsupervised or supervised segmentation? So we don't have much time, and I want to show you something quickly. So I go for the unsupervised segmenter here. You can see that we have a few tabs here that will represent the different stages of learning and then getting results out of the library. In the first tab here, we are going to load images and build a data set for our case. Here we have a list of the different type of images that we are going to load and their corresponding label. We are going to use unsupervised segmentation here, so all the images will be good. But as we have learned before, and this is totally true, even with unsupervised segmentation, even where the learning only uses good images, it's still better to load a few bad images during this process in order to evaluate the learning process. So I'm going to load the good images here. I create a label called good, just renamed it here. I right-click and I add images to the good label here. I just downloaded a sample data set in my download directory this afternoon. That's something all the images you can get from our website. I take the data set easy segment unsupervised. I chose to show you fabric, and I have a set of good images. Not so many, 1, 2, 3, 7 of them. I'm going to load all of them, so that's really the proof that unsupervised segmentation can work with a very little number of images, and you can double-click on each of them here. That's the kind of fabric I would like to inspect here. It's a perfect case for unsupervised segmentation because the pattern is very regular. Yet we can get very challenging cases here, very challenging defects. As I said, we don't need not okay or bad images for this case, but I'm going to show you how to load them anyway. If you use classification, for example, you have to have different types of images and different types of labels. So in this case, you click Add Label. Here I will have bad images, and similarly, I'm going to load a few bad images in my data set. So I go back to this directory, double-click bad, and I have a few bad images that I'm going to add to the data set here. So I have all of them here, and then I have good and bad images here. In a second step here, we have a tab which is called Tool Properties and Data Augmentation. We have not talked about data augmentation today. I believe it's a very interesting, very useful process in machine vision. In deep learning, the process of using data augmentation is the process of artificially adding images to the data set based on basic transformation of the real images that you have. And this is really useful because this can help building a tool, a neural network, which is much more robust, which will, for example, be more robust towards using different camera, different illumination or noise in the image, for example. So I'm going to enable data augmentation, and here you can go through the type of data augmentation that we provide, and you can see that we provide a lot, and you should use the data augmentation functions that are really relevant for your case. For example, here we have a piece of fabric. I can really imagine that in a real application, that piece of fabric could be anywhere left, right in the image, maybe rotated a little bit. So I'm going to allow some rotation. I'm going to allow some shift in the image and maybe some scaling, because we are not always sure that the camera will be at the same distance to the object to be inspected. So these are the different types of data augmentation that you could use here. We could also play with the color and luminosity if you expect some changes in luminosity in the image. What will this do? This means that the library will in itself create many variations of my sample images, my dataset images here, and they will all be used to train the model. Next step, the training. I'm not going to do it here because depending on the machine, this takes from minutes to hours, and I really do not have a GPU here. You can see that the system will automatically split the data set into a training and a validation data set, and we will get some real-time information during the training. In order to continue the demonstration, I have another instance of the deep learning studio here that I have loaded with the data set just before the presentation. And so this is what you would see after the training. After the training here, you have some information of what happened during the training here. You see that we went through 49 iterations here, but most of the information is actually in the dataset result. And we have the same type of histogram, score histogram that we have seen just right now, and which allows us to choose a suitable classification result. And this is also a very, very easy case. This is the confusion matrix here. The system has been able to perfectly differentiate between the good sample and the bad samples here, which are here, and this is the kind of defect. Let's try to classify images here, and that's the last tab number 5. When you want to classify a new image here, you just click on Open Image. I have one here, and then you immediately see the result. Click on Result and choose to highlight the segmentation, because segmentation here, and this you see the in the red yellow overlay, you see the result of the segmentation highlighted. So this is the kind of defect that we can detect, maybe a bit more challenging here, much smaller defect here in the piece of fabric, another type of defect here, yet a scratch that we can detect in this image. So you see that in just a few steps here, I'm already able to show you something. But the important point is that you can do this by yourself. You can do this by yourself just by downloading the tool, the Open eVision Deep Learning Studio from our website.
Okay.
Thank you.
2 minutes warning.
Okay, good. And just 3 more slides to go. And thank you, Peter. Why would you be interested in the Open eVision Deep Learning libraries? Why? Because we focus on factory automation. #1 market of Euresis is in Asia, and we have a lot of applications in the semiconductor, electronic inspection. We have selected the deep learning techniques which are suitable for factory automation inspection and defect detection. And we have made an API, which is the set of functions, which is particularly easy to use and easy to integrate into machines. So this is part of the code that you can use for dataset creation and training. I'm not going to go through it, but you can see that you just have a class, you create a classifier class, you add images to it. It's quite simple and it's really easy to use. Another advantage of Open eVision deep learning libraries are the deep learning studio application in itself. The application that you have just seen is free of charge. It does not require licenses to run. Of course, it's only for evaluation. You can build your data set. The libraries themselves are not free, but the evaluation tool is free. And this is great because most of our customers do not want to send us any image. So you can use your own images and you can evaluate very easily our tools using your own images. Please head for our download page. You go to Open eVision. Latest version is 2.13. Click on Open eVision Deep Learning Studio to download it and install it. And while you are there, you can also download additional resources. We have a few data sets here for classification, unsupervised, and supervised segmentation. I recommend the coffee data set, which is super impressive. Last but not least, our customers are machine makers. They build machines in quantities. Our pricing is suitable for the machine market. We sell the 3 libraries, classify, segment, and by the end of the year, easy locate in a bundle. So you don't have to choose beforehand. You get all 3 of them. Deep Learning Studio is free. If you want to evaluate it into your own application, we also offer a 30-day evaluation license. We have videos on YouTube with all the tutorials you need, much more complete than what I have shown you, in Chinese, Korean, German, and Japanese. And we have a staff all around the world who are there to help you. Please go to our webpage, Euresis.com, to get contact information in your own country. Thank you.
Hello, Marc. Thank you very much. And I see the first questions arising at the moment. And the first one is, does Euresis offer a solution for inference as well?
Yes, true. I mean, the solution, yes, of course. So the library contains training and then contains inference. So there are functions where you can only load the model and apply it in the machine.
Mm-hmm. Another question is of the Open eVision deep learning tool run in Linux?
Not today, next year. We will have a prototype of a Linux version by the end of this year, and in 2021 there will be an official version of Open eVision compatible with Linux.
Mm-hmm. And if I use your Open eVision deep learning library, do you secure that my data will be private, or do you store my data in any way to optimize your models?
Everything is local. So we do not transfer your data anywhere. There is no cloud processing. The training process, the inference, it is all local. Nothing will leave the PC on which you are working.
And another question, in the unsupervised mode of Easy Segment, how do we check if the tool works correctly if it trains only with good images?
Actually, yeah, if you train only with good images, then after the training, you have to provide some bad images and check whether it works or not. But even if the training is done only with good images, we always recommend to add bad images to the training data set. They will not be used for the training itself, but they will be used to evaluate the training process.
Okay.